So far, we've done polynomial addition, polynomial subtraction, polynomial multiplication, and the easy part of polynomial division called the greatest common factor. But today, we're going to get into actual polynomial division in a way that's called factoring. So factoring is when we divide a polynomial. It is division, but it's a very specific kind of division. So when we divide the polynomial into its linear factors. Okay, this is basically reverse double distribution or reverse multiplication because it's, division. Now, factoring is a very specific type of division for polynomials, and the way that we're going to learn how to factor or divide these polynomials into their two factors is what's called the swing and divide method. Now, to do the swing and divide method, you got to be able to set up your own X puzzle to then solve and use. So the reason we've been doing these X puzzles for a while is because we're going to need to set our own up and then use it to finish factoring this polynomial. Some things I want you to notice about the X puzzles that we're going to be setting up for ourselves is that on top, you're going to be multiplying the a times c of a function. On the bottom, you're going to be multiplying the b of the function. And on the sides, you're going to be creating some little fractions with a as the denominator. Now, I'm sure you're like, Ms. Quigley, great, you told me a, b, and c, but I don't know what the heck those are. So in a polynomial, like the polynomial you see here, there is an a value, a b value, and a c value, okay? The a value is the letter or the number associated with the x squared term. So in this case, 3 is my a value. The b is the number that is associated or next to just the regular x. It is typically in the center of this trinomial. And then the c term is the constant. C for constant. It's just the good old-fashioned number by itself. So in the swing and divide factoring, which really it should be called divide and then swing because the swing part comes at the very end. But what we're going to do is we're going to set up our own X puzzle and then solve it. So remember, we want to put a times c in the top. A times c is 3 times 6. That's 18. B for bottom is 11. And then my a's go underneath the fraction bars. Check, check, I've set up my X puzzle. I am prepared to start factoring this trinomial and get it as a product of its linear factors. So I solved the X puzzle like we've been learning, okay? We're going to look for factors of 18 that will multiply to 11. The things that multiply to 18 are 1 times 18, 2 times 9, 3 times 6. Now the magic number sheet, since the top number is positive and the bottom number is positive, tells me that the signs of the numbers that I'm going to use are both positive. How do I use one of the rows for the factors of 18 to create 11? Yeah, hopefully you notice 2 and 9 multiply to 18 and add to 11. Now that's why we spent a while on X puzzles. The next step you're going to do here to go back into factoring steps and not X puzzles is reduce each fraction that we've just created if possible. Does the fraction 2/3 reduce? No, we're going to leave it as a positive 2/3. But does the fraction 9/3 reduce? Absolutely. 9/3, 9 divided by 3, that's 3. Okay? All I need to do after that is write them as linear factors, which means I'm going to take these numbers and I'm going to write them in a parentheses with an x. The first one is going to be x plus that 2/3. And the second one is going to be x plus 3. Now technically that is almost done because the swing part comes in handy here. We've done the divide that was inside the X puzzle, but the swing happens here. If you have a fraction in those parentheses, we have to swing the denominator forward. So that means I'm going to take the denominator of 3 And instead of writing 2/3, I'm going to swing that denominator and slip it right in front of the x so that this would be 3x plus 2 and x plus 3. This is the linear factors, or the factors of the polynomial we started with. It's reverse multiplication. If you remember back to when we did multiplication either in the Punnett squares or with FOIL or double distribution, we started with a problem that looked like this and ended with a trinomial that looked like this. This process is the reverse. We're going to take a trinomial and we're going to write it as a product of its linear factors. Let me walk through this one more time now that you've written it all down so you can just see the process of factoring. We identify A, B, and C. We set up our own X puzzle where A times C is the number in the top and B is in the bottom. Then we just have to, and A's are underneath the division, so there's your divide step. We simply solve the X puzzle and pop those numbers on top in the numerator. If I reduce both fractions, if possible, and then I write them as a product of the linear factors. I play cleanup at the very end by taking any denominator left and swinging it back to the front, sneaking it in front of the x term. Now we could always check our work and make sure that we have factored these things correctly by double distributing or using the Punnett square to check, and we will do that in class. Now let's check out the inside of these notes. We have 6 practice problems we're going to do. The second side, number 7 through 10, are for next class, so don't lose your notes because you're going to need them. It says to factor the following polynomials. All right, well, we know we need to set up our X puzzle, but we first need to know A, B, and C. Now, A is invisible right now. That x squared has a coefficient of 1 that's not showing. So if you need to show it so it's easier, that's fine. Let's set up my X puzzle. We know A times C goes in the top, so that is 1 times 6, or 6. And B for bottom, like the little minions, 7 goes in the bottom. My denominators are both 1 because A is equal to 1. I need to know what numbers will multiply to 6 and add to 1. So here are all of the factors of the number 6. If I think back to my magic number sheet, if the top number is positive and the bottom number is positive, then that means that both of my side values are both going to be positive. The only way to make 7 out of that list is positive 1 and positive 7. Great. The X puzzle is finished. I divide if possible. 1 divided by 1 is 1, and 7 divided by 1 is 7. So I take that positive 1, and I write it as a linear factor, and I take that positive 7, and I write it as a linear factor, and voila, I have the linear factors for that trinomial. X plus 1 times x plus 7. Again, if we FOILed this or you did double distribution, we'd end back with the trinomial we started with. On this next example, y'all are going to help me set it up. Okay, we'll solve it together, but we're going to set up the X puzzle together. What would I put in the top of this X puzzle? Yeah, it would be 8 because I'm going to be doing A times C, which is 1 times 8. What goes in the bottom of the X puzzle? B for bottom, so that means 9 goes in the bottom of the X puzzle. What number should be my denominators? The A value is 1, so my denominators are 1. Fantastic. Now we do a quick little X puzzle just to try to figure out what numbers belong in the sides. Magic number sheet tells me it should be positive, positive, and pretty obviously it's 1 and 8. We reduce our numbers. 1 divided by 1 is 1, and 8 divided by 1 is 8. And then I grab these numbers that I got out of my X puzzle, and they become part of my linear factors. Woohoo! We've factored that trinomial. We've done reverse multiplication. Now this third one is for you. I want you to pause the video and I want you to try this one. Set up an X puzzle and factor the polynomial. If you factored this correctly, you should have ended up with x minus 2 times x minus 6. Pause the video for a second and look through the work to see if you need to correct any mistakes on your notes. Now, it is not always going to divide by 1, because if you look at question number 4, and if we label A, B, and C, A would be 3 this time, B would be -7, and C would be 2. So when we set up our X puzzle, we need to make sure we actually do A times C to pop that number in the top. You should not put a 2 up here. Okay, remember this is A times C. 3 times 2 is 6. -7 goes in the denominator, and what number should be underneath my division sign? Yeah, it should be a 3 because it's A. So again, we're just looking for the factors of the top number, which is 6, that will add to -7. The magic number sheet tells me that if the top number is positive and the bottom number is negative, then they're both going to be negative factors. So if I use 1 and 6, -1 and -6, sorry, you'll see that you get -7. Now here's where it's very important that you do your, what's this called? Simplifying. Wow, I just had a brain fart. -1 divided by 3 is -1/3, and -6 divided by 3, that's -2. So when I drag these things down to become part of my linear factors, I have to remember that there is an extra step when I have denominators. This process is called swing and divide, when really it should be called divide and swing. So we're going to take that bottom number, that denominator in the first linear factor, and we're going to swing it forward. Sneak that 3 in front of the x, leave everything else the exact same. And that, my friends, is the linear factors, or the factors of the trinomial for number 4. We're going to do number 5 together, and then I'm going to leave number 6 for you to try on your own, because number 5 has something very interesting happen. If we go to set up our X puzzle, we know that A times C goes in the top. We know that A is the next to X squared, and C is by itself, so A times C would give me -25. But then I go looking for the B value, and there's like nothing else. So this equation is missing a term. It's really like 1x squared plus something minus 25. My friends, that something is a 0x because there are no x's. So if your middle term is missing, it's a 0. Now this one's really fun because the magic number sheet tells me that if the top number is negative and the bottom number is positive, or negative, then I have different options. And while 0 is neither positive nor negative, I still know that these signs are going to be opposite. The only way to multiply two numbers and get a negative number is if the signs are opposite. Out of the factors of 25 that I've listed on this paper, which two can I add together, one positive, one negative, and get 0? Yeah, -5 and 5, if I add together, gives me 0. They cancel out. We do our simplification. -5 divided by 1 is -5, and 5 divided by 1 is 5. So my linear factors are x minus 5, x plus 5. This process doesn't change no matter what numbers I give you for the trinomial, or in this case of number 5, the binomial, 2 terms. So I want you guys to try the last one on your own. Okay, I'll set up A, B, and C for you just as a little bit of a help. But when you press next on this video, it will, I'm almost using the wrong color, it will tell you the linear factors. So make sure you actually are trying this one on your own before you press next. How'd you do? A lot of students will get stuck on this red step and think that they're finished. But remember, if you have a denominator left in one of your numbers, so if one of your linear factors is a fraction out of the x puzzle, you're gonna have to swing that denominator forward. A times C went into the top, which is 4 times 3, that's 12. B for bottom, 13 goes in the bottom, and my A value is 4. I then simplify my fractions here. 1/4 doesn't simplify, but 12/4 is 3. That becomes part of my linear factors, and again, if I have a fraction or a denominator in one of my linear factors, I'm going to have to swing that denominator forward, not to the front of the parentheses, but in between the parentheses and the x that it's attached to. 4x plus 1 times x plus 3 is the linear factors for this trinomial. Now, like I said, the problems 7 through 10 are going to be for next time, so don't lose these notes because we're going to be starting with this information and doing those problems for homework next time. Factoring is one of my favorite things we do, so even if you hate it, you're going to have to pretend like you like it because I like it so much. But I will see you guys in class, and we will just practice a bunch of factoring polynomial questions.